Hello students, you are welcome to Prepclass Tutors. And with you is Mr. Chima, and I am your Prepclass tutor on chemistry. Looking at your screen, you will see that today we are going to be handling Jamb Chemistry 2019 past questions. I don't know if you've been following our videos or if this is the first time of you joining us on this section. In our previous videos, we've solved past questions on Jamb 2020 from question 1 to 40. We've solved past questions on the same Jamb Chemistry 2019 from question 1 to 20. So today, we are going to be looking at questions 21 to 25. So now, first and foremost, students, do not forget to subscribe to our YouTube channel. Try to like our videos. When you look below there, you see a comment section. We urge you to drop a comment on our comment section box so that we'll know how helpful our videos have been to you. So quickly, without wasting your time, let's move. Question number 21 says, a solid begins to melt when, let me pick my pointer and let's move on. A solid begins to melt when A, is it when the constituent particles acquire a greater kinetic energy? B, is it when the energy of vibration of the particles of the solid is less than the intermolecular forces? C, is it when the constituent particles acquire energy above the average kinetic energy? Or D, is it when the energy of vibration of the particles of the solid equals the intermolecular forces? This looks rather confusing, but let us explain the process that takes place when a solid or before a solid starts melting. Now I said here, when a solid is heated, its molecules acquire kinetic energy. As a result of this, they start moving and vibrating faster and faster. What does that mean? When a solid is heated, the molecules of the solid, let's take for example ice, the molecules acquire kinetic energy because that heat that is being supplied to the solid makes them to start moving randomly, to make them energetic, thereby acquiring kinetic energy, and they'll start moving haphazardly, they'll start moving, or they'll be shaking because at first, molecules in a solid are static, they are immobile, and they are held by strong intermolecular forces or strong cohesive force. When you heat them, as they absorb heat, in that their fixed position, they're moving, trying to break that intermolecular forces that is holding them in place. Do you understand? So now, the heat that is being supplied to the solid now translates to kinetic energy, causing those molecules to start moving and vibrating. Now, I said that as kinetic energy increases, that is, as you continue to increase the heat or supply heat, the vibrations of the molecules increases, and the intermolecular forces holding the particles become weaker and weaker. It's just like you've watched a movie where they tied a man to a rope, or they tied a man with a rope, maybe on a rope, and tied it to a tree. If the man continues to pull, drag, little by little, that rope will continue to become weak. That's the same thing that is happening here. That rope may continue to become weak so that the man continues, he may cut the rope. That's what happens here. So as they continue to absorb heat, they continue to move, small. And as they are moving randomly, little by little, the intermolecular forces holding the particles is becoming weaker and weaker. Now I said that a point is reached. That's when they continue acquiring kinetic energy, or when you continue heating them. A point is reached when the average kinetic energy of the molecules, due to their vibrations, becomes equal to the intermolecular forces holding the molecules of that solid. At this stage, the solid starts to melt. So when that kinetic energy, that their movement becomes equal to that intermolecular forces that is restricting them, the solid now begin to melt and change to the liquid state. In the liquid state, there are still intermolecular forces, but they are not as strong as that of the solid states. Do you understand? So the molecules can move about, but in short distances. But if you continue heating them, you increase the kinetic energy, and what happens? They will break that intermolecular forces completely and translate into the gaseous state, where there will be nothing restricting them, and they'll be moving at what? Great speed. So before a solid melts, the average kinetic energy of those molecules as they are moving must be equal to the intermolecular force holding them in ransom. Do you understand? So because of that, the best choice is D. You can see that out of all the options here, it is only D that relates to what I just explained, that the average kinetic energy of the molecules due to their vibration becomes equal to the intermolecular forces holding the molecules. So you can see here that D states energy of the vibration, that's the average kinetic energy of the molecules of the solid, equals intermolecular forces. So the best choice is D. I don't know if you have the past question with you. It's like they went for C, but it is wrong. It is somebody that is answering the question. Are you following? It is wrong. The best choice is D. Okay, 22. And I'm sure that this one too, when they were preparing this material, I'm sure that this one too, if you look at a past question, you see that they also went for the wrong answer. We will solve it now. The oxidation state of chlorine in HClO4 is, the oxidation state of chlorine in HClO4 is, now, I said that HClO4 equals 0 because oxidation state of a neutral compound is 0. When you are not seeing any charge here, charge means they may write HClO4. You now see on top of here, you may see maybe -2 or -1, as in SO4 2 minus, CO3 2 minus, NO3 minus. That charge, everything will be normally everything will be equal to the charge. But since you are not seeing any charge here, that means the charge there is nothing, is 0. So because of that, HClO4 is 0. So if you add all the oxidation state of everything, hydrogen, chlorine, and oxygen, it must give you 0. Now, before you solve this, you must know something. Look at what I note in this box. Hydrogen has an oxidation state of +1, except in hydrides, where it is -1. This thing is not a hydride. Oxygen has an oxidation state of -2, except in peroxide where it is -1. It is not also a peroxide. So since it's not a hydride, the oxidation state of hydrogen here is +1. Since it's not also a peroxide, the oxidation state of oxygen here is -2. Putting that into consideration, you have that HClO4 equals 0. So that means H plus Cl plus 4 atoms of oxygen, because it's O4, 4 into bracket 0 equals 0. Oxidation of hydrogen is what? 1 plus Cl is unknown, plus 4 times oxidation of oxygen is what? -2 minus 2 equals 0. So that becomes 1 plus Cl plus 4 times -2 give me -8 equals 0. So that's 1 plus Cl plus times minus, this bracket means multiplication, plus times minus equals -8 equals 0. So +1 or +1 minus 8. You can say 1 minus 8, or you can say +1 minus 8. Of course, that will give us -7. So Cl -7 equals 0. When you take -7 over to the other side, it becomes plus. So Cl equals +7. It's like they went for -5. That's a wrong option. The best choice is +7, as you can see from our calculation. +7. And because of that, the name of this compound becomes tetra, from this 4 here, oxochlorate 7 acid. Since hydrogen is coming first, it is an acid. Either you can say hydrogen tetraoxochlorate 7, or you say tetraoxochlorate 7 acid, whichever one. So that's for that. Question number 23. Ammonium chloride undergoes a reversible reaction to form ammonia and hydrogen chloride. Okay. Now the reaction above can only attain equilibrium if A, a gaseous reactant is added, B, one of the products is removed, C, it is in a closed system, D, it is an open system. Now they are asking us what will make this equilibrium, or what will make this reaction to attain equilibrium. What will make this reaction to attain equilibrium? Now, so I'm going to give you a condition, or before or below here, you can see I've even already given you the conditions that are must be attained for a chemical system to be in equilibrium. So I said, for a reaction to attain equilibrium, one, it must be a closed system. Closed simply means covered. Finish. The container where the reactant particles is undergoing reaction must be covered to prevent gaseous constituent from vaporizing. Do you understand? So it must be a closed system, therefore preventing escape of gaseous constituents. Like in this case now, these two are gases. If you open it, everything will just vaporize out. Two, it must be a reversible reaction. Of course, this reaction is reversible. As such, can be approached either from the forward reaction or from the backward reaction. Now, you must understand that in a reversible reaction, both the forward reaction and the backward reaction are taking place together. So I say three, that both the forward and backward reaction occur at the same time and rate. So, for a system to be in equilibrium, it must be closed. It must be a reversible reaction. Both the forward and backward reaction must be occurring at the same time and at the same rate. So let's look which of these three conditions is close to any of the answers. You can see here, a gaseous reactant is added. No. One reproduct removed, and of course it is in a closed system. It is in an open system. No. You can see that out of these three, our best choice is a closed system. A closed system that best describes what happens or if this reaction will be in equilibrium. So it is a closed system is your correct answer. Question number 24. Nuclear fission involves the splitting of a heavy element into two nuclei of nearly equal masses with the release of energy and radiation. B, equal masses with release of energy. C, equal masses release of energy and radiation. D, unequal masses without any release of energy. What's a nuclear reaction? The spontaneous emission of a radioactive element. The process whereby a radioactive element may disintegrate, leading to evolution of a large amount of heat and what? Radiation. We have two types. Nuclear fission means breaking of a radioactive element. Nuclear fusion means coming together of two lighter radioactive elements. So now I said nuclear fission is a process in which the nucleus of a heavy element is split into two nuclei of nearly equal mass with the release of energy and radiation. So it is nearly equal mass. So you can see in this reaction here, uranium-235 undergoes what? Bombardment. It was bombarded with neutron particles. So because of that, it will not undergo this kind of radioactivity is known as artificial radioactivity. When you force an element that is not radioactive to undergo radiation, it's known as artificial radioactivity. I believe that this uranium-235, you have uranium-238. I think that one is the one that is radioactive. This uranium-235 is stable. But if you want it to be radioactive, sometimes they will fire it with neutron particles. And when you do that, it will split into two other lighter nuclei with a large amount of radiation. Look at these three. That's more of the neutron particle. This neutron particle is the radiation. This one too here is the radiation. The fire, use this radiation to fire this one to split into two lighter molecules with the evolution of more of this neutron particle that is radiation and large amount of heat. Very, very large amount of heat. This is the kind of heat that can consume a whole city. It's too much, large amount of heat. Now, I said that some of the masses of the products, that is this barium and krypton, is a little less than the original mass of the uranium particle. This change in mass is known as mass defect and can be determined by Einstein equation, E is equal to mc squared. So the change of mass, it is almost the same thing, if you weigh these two, but there's a difference, a slight difference in mass. So that slight difference in mass between when you add these two and this one is what we call mass defect. So that's why we say nearly equal. So because of that, your best answer is A, nearly equal masses with the release of energy and radiation. You can see this place, you can see this radiation, this neutron particle is radiation, and the energy. The energy is usually in form of heat, fire, heat, large amount of heat. Question 25 and the last for today. The most common ores of iron include, is it hematite and malachite and limonite? Is it charcoalite, calamine and bonite? These are funny words. Is it magnetite, hematite and limonite? I think I'm saying the correct answer. Is it malachite, charcoalite and bonite? All these ones are not really. Let's see, Sha. Now I said it that common ores of iron are hematite, Fe2O3, magnetite, Fe3O4, iron pyrite, FeS, iron 2 sulfide, iron 4 sulfide, siderite, FeCO3, and limonite, Fe2O3.H2O. So which of all this one now relates with what we are given? So I can see magnetite, hematite, and limonite. Hematite, magnetite, and limonite. Hematite, magnetite, limonite. Magnetite, hematite, limonite. So our correct answer is C. Magnetite, hematite, and limonite is the best answer. Alright, students, we've come to the end of today's section on chemistry with Prepclass tutors. You can see below here, there is a link here. We urge you to copy and paste this link on your browser. It will help you to join us on our WhatsApp group. When you join us on our WhatsApp group, you'll be getting updates and infos on the latest video we have on our YouTube channels. So I believe you've enjoyed today's section. So till we meet again, I still remain Mr. Chima, your Prepclass tutor on chemistry. Bye, and do stay safe.